This is one of a series of 6 general revision videos for higher tier GCSE maths. These are based on the pixymaths.co.uk revision maths, and this is the algebra version. So I'm not going to be reteaching anything in this video, I'm just reviewing how I would do these questions and going through the sort of easiest method for each of them. So expanding double brackets is the first skill. Firsts 2x squared, outsides 8 times 2x, insides 3x, lasts 3 times 8 is 24. Then combine the middle two terms because they're both terms in x, so that is 19x plus 24. Same thing here, but watching out for the plus and minus signs. So I've got 3x times 4x is 12x squared. Outsides, minus 1 times 3x is minus 3x. Insides, minus 2 times 4x is minus 8x. Minus 1 times minus 2 is plus 2. So 12x squared minus 11x plus 2. This one, triple brackets, I need to expand one pair of brackets first and then multiply by the final bracket. So that gives me the first two brackets, x squared, outsides would be plus x, insides plus 3x, so altogether that is plus 4x. If you take two lines to do that, that's fine, but I've just done it in one to speed things up. 3 times 1. And that is all multiplied by the third bracket. At this point I expect 6 terms out of this section. I'm going to multiply every term in this bracket by x, and then every term in this bracket by minus 2. So that gives me x cubed plus 4x squared plus 3x. And they're all multiplied by minus 2 now, so minus 2x squared minus 8x minus 6. And finally combine the x squared and the x terms, so that gives me x cubed plus 2x squared, so that's 4x squared minus 2x squared. I combine my 3x and my minus 8x, that is minus 5x minus 6. My final answer there, x cubed plus 2x squared minus 5x minus 6. If you expanded the other bracket first, that would be fine as well, but we always just expand one pair of bracket and then multiply that through by the final bracket. Okay, factorising and solving. Starting with an x, so that is an x at the beginning of each bracket. I need numbers that multiply to 15 and combine to minus 8, so just thinking I'm going to have two negatives in it because it's ended up with a positive number at the end, but I've got a negative there, so that must be a minus times a minus. Factor pairs of 15 are 1 and 15, 3 and 5, and that's it, a combination of minus 3 and minus 5 gives me plus 15. That equals 0. So to solve it, that is x equals 3 from that bracket, or x equals 5 from this bracket. This one, 4x squared minus 49, is the difference of two squares, this special technique where if there's no x term in the middle, we look for a bracket with a plus sign in the middle and the same bracket with a minus sign in the middle. I look for the square root of that bit, which is 2x, and the square root of that bit again goes in here, and the square root of 49 is 7, so this is 2x plus 7, 2x minus 7. If that equals 0, then either x equals minus 7 over 2 from that bracket, or x equals 7 over 2. And just to remind you, if you find that complicated getting these numbers, remembering how that works, you can just take each bracket and set it equal to 0, because that's what the principle is anyway. So if I look at that first bracket and then try to solve that equation on its own, I get that answer that I'm looking for there. Same would be true for the second bracket. So you just put the whole bracket equal to 0 and solve. This one, I would be doing trial and error to find the two brackets, but I know that I'm starting off with more than 1x squared. So if there's a higher coefficient than 1, we sometimes use that longer method, the AC method it might be called. I would be multiplying the A position and the C position, so that's 6 times minus 3, which is minus 18. I'm just going to look for factor pairs that add to 18, multiply to 18, I mean, so I've got 1 and 18, 2 and 9. They have a difference of 7, so that's going to be it. The other pairs would be 3 and 6, and that would be it. So 2 and 9, I need to think of plus 1 and minus the other. I'm going to end up with plus 7, so it's going to be plus 9 minus 2. So I split that middle term. 6x squared plus 9x minus 2x minus 3 equals 0, splitting that middle term into the 2. Then taking out the highest factor of this first pair, which is 3x, leaving me with 3x times by x, 2x plus 3. Three for the 9x there. And then I'm going to put, just factorising that so that I get the same bracket, I've got minus 1 times 2x plus 3 there. Leaving me with first bracket 3x minus 1, second bracket 2x plus 3 equals 0. Same technique as before. X is either 1 over 3 or x is minus 3 over 2. So those are definitely more advanced, those ones where we've got a higher coefficient than 1, not just x squared but more than 1x squared. Okay, simplifying algebraic fractions. The rule with this is always factorise first. So whatever you've got, it's going to be easier to deal with once it's factorised. So this first fraction, I've got a denominator. That one is difference of two squares, because I've got no middle term, so 2x plus 1, 2x minus 1, the square root of those things. Again, I'm going to use trial and error this time rather than the long method, because I know that my brackets both end in 1. If I'm ending up with a minus 1, I've got a plus 1 and a minus 1. And I'm also looking at these brackets and thinking that if I'm going to be able to simplify it, one of these factors is going to be the same as the one on the denominator. So I know I've got a plus 1 and a minus 1 at the end. And let's see what happens if I put, at the beginning I've got a 2 times a 3 to make 6, most likely. So that would be plus 2x, so I'm going to put 2x in there. Plus 3x minus 2x is going to be the combination I need in there. And that is just trial and error, really, juggling through the numbers in my head. But that allows me to cancel those common factors, giving me a final answer of 3x minus 1 over 2x minus 1. Simplifying this, by the way, that cannot be simplified any further. I can't cancel the x's or the minus 1s or anything. There's nothing that is a common factor of both the numerator and the denominator, so that's that. This one, if I'm going to add the fractions together, they need to have the same denominators. So numerator, I'm going to multiply this fraction by x plus 1 over x plus 1. And I'm going to multiply this fraction by the denominator of the other fraction. So I now got the same denominator on both fractions. I can now expand those to add them together. So that gives me x squared plus 3x plus another x, so that's plus 4x plus 3. Plus here 4x squared, and 4x times minus 2 is minus 8x over that same denominator, 4x x plus 1. I perhaps didn't need to expand that top bit, but it might be that I find a common factor somehow when it's all combined. So x squared plus 4x squared is 5x squared, plus 4x minus 8x is minus 4x plus 3 over 4x, x plus 1. And finally, solving this, I'm going to multiply both sides by all the denominators. Let's say multiply everything by 5 in the first stage to get rid of those denominators. So multiply that by 5 and I get x minus 2. This multiplied by 5, I'm just going to have to do that in the numerator. And I haven't got rid of that denominator yet. And multiplying that by 5 gives me 8. Second step, I'm going to multiply everything by the other denominator, x. And this is where I really need to be careful to multiply every single term by x. So that is x squared minus 2x. That stays as it is because I'm just multiplying by x to get rid of that denominator. And this also needs to be multiplied by x on both sides. So I'm going to expand that bracket now. I've got x squared minus 2x plus 10x minus 15. And I'm just going to bring this 8x over to this side as well, getting ready to solve by making everything equal to 0. Combining all of those things, that gives me an x squared minus 2x minus 8x is minus 10x plus 10x. So x squared, they all just cancel each other out, and I'm left with x squared minus 15 equals 0. That takes me to a much simpler quadratic to solve. X squared equals 15, and therefore x is plus or minus the square root of 15. Okay, using the quadratic formula to solve these. The quadratic formula is now given in the exam on the formula sheet on the front page. So remember, we're looking for ax squared plus bx plus c when we use the quadratic formula equaling 0. So in this case, x equals minus b plus or minus the square root of b squared minus 4ac, so 4 times a is 1, times by c, which is minus 3, all over 2 times a, which is 1. So x equals minus 7 plus or minus the square root of, so I've got minus 4 times minus 3 here, that is plus 12. So 7 squared plus 12, 49 plus 12 is 61 over 2, and that gives me x values of root 61 minus 7 divided by 2, 0.405, or other way around, minus 7, take away the square root of root 61 divided by 2, minus 7.41. Both of those to 3 significant figures. This one, similar, but I've now got a number in front of the a, so x equals minus b plus or minus the square root of b squared minus 4ac all over 2a and that gives me x equals, look, 3 squared plus 8, it's root 17. Divided by 4, x equals 0.281, or x equals, I'll do the other way around, minus 3 minus root 17 divided by 4 gives me minus 1.2 7, 8. 3 significant figures. And finally this one, first thing that needs to happen is it needs to be set equal to 0. So I need to get, I'm actually just going to add to this side x squared and take away 4 from that side. That gives me x squared plus x minus 4 equals 0. And again, just plugging that into the quadratic formula, x equals minus b plus or minus the square root of b squared minus 4ac minus 4, all divided by, I should have put it over but I haven't got space, divided by 2a, 2 times 1, so that's just divided by 2. In the bracket here I've got 16, minus 4 times minus 4 is plus 16, 16 plus 1, so root 17 again, so I've got minus 1 plus root 17 all divided by 2, which is 1.56. So x equals 1.56, or x equals minus 1 minus that, minus root 17 divided by 2, minus 2.56. Not very clear to see x equals minus 2.56 for that one. Okay, completing the square, next section. So we just need to take that second number, the coefficient of x, and divide it by 2. Whoops, the squared doesn't go in the bracket, it goes outside the bracket. Squared, and then subtract that number squared, and then bring down the next number. So x plus 4 squared minus 14 equals 0. In this case, I'd take out that 2 at the beginning, and then deal with that bracket in the same way, half that value, and subtract that number squared, and then bring down the next number. Then I'm going to expand the square bracket, so I'm going to leave that bit as it is. I've got 2 times that. This bit, minus 4 minus 3 over 2, that's minus 4 minus 5.5, but then I'm multiplying that by 2 because I'm expanding that bit of the bracket. So I would be multiplying everything in here by 2. I've done that to the first bracket. Second bit, minus 4 minus 3 over 2, and then I multiply that answer by 2, gives me minus 11 equals 0. Okay, iterations. This iterative formula tells me that each subsequent x is the previous version of x cubed minus 3 and then divided by 8. So if I'm told that my first value is minus 1, my second one is going to be that first value cubed minus 3 all over 8. So that gives me minus 1 cubed minus 3 over 8 is minus 0.5. And my third version of x, x3, is going to be my previous result, cubed minus 3 over 8. Which gives me minus 0.390625. And in general with these I would write out the full number unless you're told to round it to a certain degree of accuracy. Okay, simultaneous equations. First one we have to write our own. So 2 sandwiches, which I'll call S, and a juice, which I'll call J, cost 3.40. 4 sandwiches and 3 juices cost 2.70. What's the cost of a sandwich? So I need to set up my simultaneous equations. I've got 2s plus j equals 3.4, £3.40. 4 sandwiches and 3 juices cost £7.20. Solve them. In order to solve them, I need to eliminate one of the two variables. I'm going to multiply this whole equation by 2 so that I end up with 4s there as well. 2 times by 2 is 2j, times by 2 gives me 6.8. And then I'm going to subtract these two equations from each other. So 4s take away 4s is 0, 3j take away 2j is 1j, 720 take away 680 is 40p or 0.4. Tells me a juice is 40p. If I go back to the first one, 2 sandwiches plus a juice is £3.40, 2 sandwiches plus 0.4 is £3.40, therefore 2 sandwiches is 3, and one sandwich is 150, and then I'll check that with my other equation that I started with. Is it true that 4 sandwiches plus 3 juices cost £7.20? So 4 times £1.50 is £6. 3 juices £1.20. I mean, so yep, £6 plus £1.20 is £7.20. So that is correct, and the answer is cost of a sandwich is £1.50. This next one is solving simultaneous equations where one is a quadratic. In order to do that, I have to, in some way, replace an x or a y with the other equation. So in this case, because I've already got written y equals x plus 4, I'm just going to replace this y with the x plus 4. That gives me x plus 4 equals, so this one is x plus 4 equals x squared plus 4x. Set it equal to 0 because it's a quadratic, so 0 equals x squared. I've taken an x from this side, so that is 3x from both sides. Taking the 4 from both sides, minus 4. 0 equals, factorising that, two numbers that multiply to minus 4 and add to 3, so that is plus 4 minus 1. And that gives me x equals minus 4, or x equals 1. And if that's the case, when x is 1, y equals 1 plus 4, which is 5. So my solutions are when x is 1, y equals 5, and when x is minus 4, y equals 0. Minus 4 plus 4 is 0. So those are my two solutions given as coordinates, but you could also give them as x equals 1, x equals minus 4, y equals 5, y equals 0. And we just check both of those with the second equation. 1 squared plus 4 times 1 is 5. That works. Minus 4 squared is 16. 16 plus 4 times minus 4, that's 16 minus 16, gives you the result 0, so that one works as well. And finally, solving, this is where a circle graph crosses a straight line graph. In order to do this one, I need to substitute the x plus 8 into this equation. So that gives me x squared plus y squared as x plus 8 is 34. I've now got an equation that's just in x, so I can solve it. X squared, expand this bracket, x squared plus 8x is 16x, plus 64 equals 34. Collecting like terms and setting equal to 0, that gives me 2x squared plus 16x, taking 34 from both sides, so plus 30 equals 0. I'm going to divide all of that by 2 to solve it, so that is x squared plus 8x plus 15 equals 0. And I'm looking for 3 and 5, two numbers that multiply to 15, add to 8. So x is minus 3, or x is minus 5. And to get my y coordinates for that, I know that y is the x coordinate plus 8, so I've got minus 3 plus 8, so when x is minus 3, y is 5. When x is minus 5, y must be 3. And those are my two solutions there. In an exam, I would present them more clearly as solutions. I've just run out of space on this page. Okay, quadratic sequences. So with quadratic sequences, we are always looking at our starting point. No matter what method we use, we're looking for the second difference between the terms. So in this case, the first difference is plus 4, plus 8, plus 12, plus 16. Second difference is what's the difference between these differences. That's plus 4, that's plus 4, that's plus 4. Now this tells me that my quadratic sequence involves 2n squared. I take whatever the second difference is and divide by 2. If you know the 2a, 3a plus b and a plus b plus c method, then you will also know that it's this thing that defines the main part of the sequence. This method involves knowing that we are looking for something involving an squared plus bn plus c, and finding these different letters a, m, b, c, and knowing that these are the formulae that lead to those. So this tells me that 2n squared is in my sequence. Using the more straightforward method, or the traditional teaching method of how to find these sequences, I would then look at the sequence 2n squared. So when n is 1, 2, 3, n squared would be 1, times that by 2. I write out my list of 2n squared. That is 2 times 1 squared is 2. 2 squared is 4, multiply by that by 2 I get 8. 3 squared is 9, multiply that by 2 I get 18. And I now compare this sequence, 2, 8, 18, with the sequence that I want, which is minus 2 to 10, and I look at the difference between these. How am I going to get from 2 to minus 2? And the answer is I would minus 4 to get from there to there. How do I get from 8 to 2? I would take away 6. How do I get from 18 to 10? I would minus 8. So I look at what this sequence is, and again from 1, 2, 3, I know that using linear sequences, this sequence itself is minus 2n minus 2. When n is 1, I've got minus 2 times 1 minus 2, that's minus 4. When n is 2, I've got minus 4 minus 2, that gives me minus 6, etc. So now that I've defined that sequence, I know that if I combine this sequence 2n squared with this sequence minus 2n minus 2, I will get the sequence that I want. So the answer is 2n squared minus 2n minus 2. I'll just describe quickly using this method. If I know that a is 2, so 2a is 4, and that tells me that a equals 2. I can then use this 3a plus b equals 4, and that tells me that 3 times 2, 6 plus b equals 4, and therefore b equals minus 2, as I've got here, minus 2n. And then using all of those, I've got a is 2, b is minus 2, all three together add to minus 2, so 2 plus minus 2 plus c equals minus 2. That would also give me c equals minus 2, and that's the answer that I'm looking for there for that final number. That bit on the end is minus 2. These are a bit confusing, particularly if I'm using two methods, so I'll try and just use the original method when I'm doing this one. So first difference here, 3 plus 12 is 15. I've got 18 for the next one, and 24 for the next one, and 30 for that. So I can see that this second difference is going up in sixes, and that tells me that 3n squared is involved in this sequence, 3n squared. If I think about n, again I've got 1, 2, 3, etc. 3 times 1 squared is 3, 2 squared is 4, so 3 times 4 is 12, 3 squared is 9, 3 times 9 is 27, the next one would be 4 squared 16, and 3 times 16 is 48. So that's my sequence 3n squared, and I need to look at the sequence I've got, 3, 15, 33, 57. And I'm saying, how do I get from this sequence that I know is involved, 3n squared, to this sequence? This one I'd added 0, this one I'd added 3, this one I'd added 6, this one I'd added 9. So I can see that this sequence here that I need to add to that one is the sequence 3n minus 3, just using what I know about linear sequences. So this overall sequence is 3n squared plus 3n minus 3, and I'd always just check, does this work? Put in 1, 3 plus 3 is 6, take away 3 is 3. Put in 2, that is 12 plus 6 is 18 minus 3. Takes you back to 15. So yes, this is working. This is working fine. Okay, graphing inequalities is the next thing, and solving inequalities. So show the region satisfying x is greater than 2. So for that I need to look at the line x equals 2 and draw it in as a dotted line, because greater than means I don't want to include the line itself. And greater than 2, I'm going to the right of that line. Y is greater than minus 1. Again, dotted line at y equals minus 1. And if y is greater than minus 1, I'm thinking about above the line. X plus y is less than 5. If I rewrite that in y equals mx plus c format, y is less than minus x from both sides plus 5. Thinking about the line y equals minus x plus 5, that goes through 5 and 5. Y-intercept of 5 with a gradient of minus 1. And again, it's a dotted line. So that's the line I want. Y is less than, therefore I'm thinking about underneath that line. So beneath that line, the only region that works for all three inequalities is this triangle, which is above y equals minus 1, to the right of x equals 2, and below the diagonal line. Just solving these inequalities, I've got, firstly try and get all the x's together, so take away x from both sides. That leaves me with x plus 4 is less than minus 3. Add 3 to both sides. It's going to give me x plus 7. No, I don't know why I did that, sorry. Take away 4 from both sides, I want to get the x on its own. That gives me x is less than minus 7, which is the answer to that one there. This one, a quadratic inequality, I need to solve the quadratic first of all, so I'm just going to rewrite it as an equality, an equation. Try and factorize and solve that. That is, I need two negatives that multiply, that's minus 3 and minus 4. Therefore my critical values are 3 and 4. I think about what this graph would look like. It's a positive quadratic with roots at 3 and 4. And where is that greater than 0? It's greater than 0 in that bit and that bit. So that's where x is less than 3 or greater than 4. So x is less than 3, x is greater than 4. And if I were to write that using set notation, which is sometimes what's required, I would give my solutions as x in squiggly brackets, x where x is less than 3. Oh, it's or equal to. I should have put or equal to because the equation is or equal to at the original. Or, so u for union, or x where x is greater than or equal to 4. Haven't shown that very well. A bit more space. Here's what it looks like. X where x is less than or equal to 3, or x where x is greater than or equal to 4. Okay, rearranging formulae. That is a squiggly bracket, not a 43. Okay, rearranging formulae, some simple ones and then some more difficult ones at the end. So to get A on its own, to make A the subject, I need to divide by M on both sides. F over M equals A, so my solution is A equals F over M, the rearrangement of that formula. In this one I need to get A on its own again, so first step is to get rid of the separated term. V minus U equals AT, and now that I've got this bit on its own, divide by T, and I'm dividing everything by T, so I get V minus U over T equals A, so my rearrangement is V minus U all over T. That could also be written as A equals V over T minus U over T. That would also be correct. That's kind of the simpler version of the rearrangement. In this one, I need to get everything involving A on one side and everything not involving A on the other side. That's my first step. That's because I've got two instances of the letter A. So first thing I'm going to do is add A to both sides. That gives me AB plus A plus C equals BC. Remove any term from this side that doesn't include A at all, so that's the C. So I'll take away the C from both sides. AB plus A equals BC minus C. And then I need to factorize out the A. That's the only way to get rid of these two instances of the letter A, because I only want one in my final formula. So that gives me AB plus 1 equals BC minus C. I could factorize that as well, but I don't necessarily need to. Now divide both sides by the bracket. That leaves me with A equals BC minus C over B plus 1. And that is it, that's the answer. It could also be written as A equals C B minus 1 over B plus 1. Either way is fine. Mainly what we've done is just got A on its own, and that had to happen by factorising. So group all the terms involving A, get everything else on the other side, factorise to get 1A, and then divide in order to get the A on its own. And final section of this sheet is matching the types of graphs. So match each equation to its graph. This is y equals mx plus c, a straight line graph with a positive gradient and a negative y-intercept. So negative y-intercept would be there, positive gradient going that way. That must be graph D. Y equals 5 over x, that's a reciprocal graph. Reciprocal graphs always look like this. So that must be E. Y equals 2x cubed is a cubic graph, so it's going to look like that. So that is C. Y equals x squared minus 6, that's a quadratic graph, so it's either U-shaped or N-shaped. In this case it's U-shaped because it's a positive quadratic, so it must be A. And y equals 7x minus x is a straight line graph with a negative gradient, minus x, and a positive y-intercept, so this one with a negative gradient must be B. So whenever you're comparing graphs, always look out for those key things. Not only is the general shape correct, like a linear graph, but does it also match up with things like a positive gradient and a negative y-intercept? Always looking for all the clues that you can find. Okay, that's the end of the algebra sheet. Hope that was helpful.